Shri Swami Samartha. So in today's topic we have to study the some important polymer, that is the rubber and the polythene. So rubber, which is including in the natural polymer. So we know the elastomer are most popularly known as the rubber, right? For example, the balloon, surgical gloves, that entire thing which is made up of the rubber. So we study the monomer of a natural rubber. So for example of a monomer of natural rubber, that is the isoprene or 2-methyl-1,3-butadiene. It is the monomer of a natural rubber. Okay, so first we have to write the structure, that is the 2-methyl-1,3-butadiene. Okay, so we know the butadiene means it is the 4 carbon structure. So first we write the skeleton of the 4 carbon. Okay, so we have to write the carbon number, that is the 1, 2, 3, 4. So 2 methyl 1, 3, 1 and 3 butadiene. So we complete the valency of carbon. Is the CH2, right? So it is a 2-methyl-1,3-butadiene, or it is also called as the isoprene unit. So it is the unit of the monomer of the natural rubber, right? So if we do the polymerization process of 2-methyl-1,3-butadiene, so it forms the linear network-like structure, that is the natural rubber. Okay, so we study the how to write the structure of natural rubber. So we have to write the structure of natural polymer. We shift the double bond here. Okay. So first we have to write the C double bond C. Okay. Then this carbon is attached to one CH3 and one CH2 unit. So that we have to attach here. So here is the CH3. Here is the CH2. Similarly here we have to attach the H and CH2. So here we write the H and CH2. Okay. So polymerization process involves the more than 2-3 polymers. So the large number of this monomer unit, they combine and they form the long network. So we write the 3 link network. So here the CH2 is attached to another CH2. Same here also this CH2 is attached to the another monomer of the natural polymer. Then this again attached to C and C. Similarly this also attached to the C and C. Okay. Okay, so here is the CH2. So we have to write the H. And here then again CH3 and CH2. So this monomer is a continuation in this chain. So forming the natural polymer structure, that is the CH2 and H, and this CH2 is the continuation sign we have to given here. Okay, so this is the structure of the natural polymer. Okay, so it is a high molecular weight linear polymer. Okay, so this is the including in the natural polymerization process. The properties of the natural polymer, which is including the first is the it having the elastic property. Okay, so it is a stretching like structure. Another is the across the C double bond C, here is the cis configuration is obtained. Okay, so we observe the cis configuration in the natural polymer, and this chain is held together by the weak van der Waals forces. Okay, so these all are the properties of the natural polymer. Then we study the polythene. Then polythene. The polythene is most popularly known as the hydrocarbon thermoplastic polymer. Okay, so it is a mainly two kinds depending upon their density. That is the LDP and HDP. Right. So it is divided into the two types. LDP means it is a low density polymer and HDP means it is a high density polymer. So first we study the LDP, right? So polythene structure first we write, that is a CH2, then CH2, that is the ethene molecule which is in a continuation chain and they forming the polythene, right? So in LDP, when ethene undergoes the polymerization process at 1000 to 2000 atmospheric pressure, and we have to maintain the temperature that is a 370 to 570 Kelvin, right? Then we have to get the LDP polymer, okay? That is a low density polymer, okay? So maintaining the 1000 to 2000 atmospheric pressure and 350 to 570 Kelvin we have to maintain the temperature, okay? So this reaction is carried out in presence of the traces of the oxygen, means mostly the peroxide which is used as the catalyst in the preparation of the LDP polymer. So the properties of the LDP polymer, which is including the, it is a flexible first of all, then it is having the moisture resistant capacity, then it is a poor conductor of the electricity and having the melting point is the 110 degrees Celsius, okay? And the LDP plastic which is mostly the use in the agriculture, so the in farms the pipes that is made up of the LDP plastic. Then for the irrigation of the domestic water, the domestic water where is also the LDP polymer are used. Then in submarine cable insulation, there is also the coating that pipe which is made up of the LDP plastic. So various toys and household material that is also made up of the LDP polymer. So there are the lots of uses of the LDP polymer. So the next is the HDP, that is a high density polymer. Okay, that is the high density polymer. Okay, when ethene is heated with the 6 to 7 atmospheric pressure and 333 to 343 Kelvin temperature in presence of the Ziegler-Natta catalyst. So we know the Ziegler-Natta, it is a combination of the triethyl aluminium and titanium tetrachloride. They combine together and they forming the one structure that is called as the Ziegler-Natta catalyst. So which is the very effective in forming the high density polymer. So we have to use the 6 to 7 atmospheric pressure and 333 to 343 Kelvin temperature. Okay. Then we have to get the high density polymer. The properties of the HDP. So HDP, it is mostly the crystalline and having the melting point is the 144 to 150 degrees Celsius and it is a hard and high tensile strength, right? So it is mostly used in the making the toys and the household materials and articles like the dustbin and baskets. That entire thing is made up of the HDP. The more resistance to the chemical as compared to the LDP. So it is mostly used in laboratories also, so making some laboratory wares, right? So in next topic we have to study the different polymer and their reaction. So please go on YouTube and watch the complete video and please like, share and subscribe the Chem Guru Pallavi Vasi YouTube channel. Thank you.